Hi Deepa and Srinivas. My name is Ravi. Are you able to see my screen?
Yes.
Yeah. Informatica 9.5.1 is the latest version in the market. So we talk about this version, this Informatica training. Now, I have around 8 years of experience in Informatica, DWI applications. Okay. So we'll see. As part of this training, I'll be covering basic SQL concepts, whatever is required for Informatica, like joins, inner join, left outer join, out outer join, and full outer join. What are all different joins available in SQL? So we'll cover all these things. It will take 2-3 sessions. We'll cover these classes in the regular classes. And now this is a demo. Fine. Now we have various ETL tools available in Informatica. As you are from ETL background, it's not correct to discuss all these things. Anyway, we will see. We have Informatica from Informatica Corporation, Ab initio, Data Stage, MSBI, OWB, BWBI from SAP Corporation. Okay, so we have multiple ETL tools available in Informatica. Still, we have very good demand in Informatica in India as well as US. It's occupied more than 35% of market than other tools. So this is the history of Informatica. We have Informatica started with 5.1 version in 2001. So in 2002, 6.0, 2002 again 6.1, 2003 6.2. Then PowerCenter started on 2003, 7.1 version. As you worked on this version, right, Deepa? 7.1.
Yes.
Okay, then 8.6, then 9.1, then 9.5 is in the market right now. So we'll discuss this 9.5.1 in this Informatica PowerCenter training. Okay, so it is like completely advanced training, not like basic thing. We'll discuss complete in detail, component level, properties, everything as part of this training. So you might be knowing about this. What is ETL? Let's understand what is ETL. I think you might be knowing about this still. As part of this training, we have to discuss. Okay. So let us take a bank. The bank is doing a business. Now we are doing banking project. Bank will be having multiple applications like credit cards, loans, banking accounts, mutual funds, multiple applications. That's so now a bank want to maintain a centralized database, data warehouse to view all information at a time. For example, a credit card customer is there. He has taken a credit card and he didn't pay that amount back to the bank. So now he is applying for a loan. So how these guys will be able to identify that credit card customer is a defaulter of this bank. So these kind of questions, arise by the bank managers. Now, all these questions are in front of bank managers. What these guys need to do now? Now, these guys need a centralized database, data warehouse, in order to see all the information of that particular customer accounts, or credit card details, or loan details, whatever it may be. So, all the details in a single place, so that they can able to track the customers very easily. So what we need to do in backend, so we have to extract all the data from the different databases. Here credit cards is a one database, and loans is another database, bank accounts is another database, mutual funds is another database. So I have taken here 4 examples, but we may have 20-25 databases like life insurances, okay, investments, equities, so many are there. So Now we here just for an example I've taken 4 databases: credit cards, loans, bank accounts, mutual funds. These all are business applications from the bank perspective. So in our perspective, these all are databases. This can be a single databases or different databases. Same database or different database. It can be in Oracle, Teradata, SQL Server, or it can be anything. So now it is a database for us. Whatever the database type it may be, it is a database. Now we are extracting data from the databases here, and we are transforming the data. We'll see what is transformed. Okay, we're transforming the data and loading into the central database, which is nothing but a single database, which is nothing but a huge database. So we are loading data into the data warehouse database. So we call it as data warehouse database, right? So now we are talking about transformation. So what we do in this transformation, okay, we implement the business logic. We maintain a unique format of data. Here, if you can see, credit cards data may be in different format. Okay, first name may be first, last name may be last, and middle name would be in the middle. But in the loans, first name, surname, last name. So there is a different format. We have to maintain a unique format in order to maintain complete data at one particular place. So we have to maintain that. There is a concept called business tools. I think you might be knowing about these business tools. So what exactly these business tools does? So how to implement those business tools in our project? So these kind of things we'll see in the regular classes. Okay. So for any questions, guys?
No.
Fine.
No.
Now data transformation. So here we do different type of activities in the data transformation as discussed. Data cleansing, data scrubbing, data aggregation, data merging. We merge the data, we aggregate the data, we scrub the data, we cleanse the data in order to maintain a proper data in the data warehouse database. So we'll see in the further classes how to cleanse the data, how to scrub the data, how to aggregate the data, how to merge the data. Okay, we'll see that in detail in the coming classes. Now here, basically why we need to maintain a data warehouse database. Here you can see all these applications are built for support the business. All these applications are built for supporting the business. Supporting the business in the sense to capture the data from the business. Credit card data. It will be capturing, the application will be capturing the data from the credit card application system. Is nothing but OLTP database, online transaction processing database. Okay. All these loans, bank accounts, mutual funds, all these are online transaction processing. It is built for supporting the business application. Now, centralized data warehouse is for a reporting system to take the decisions. It's a decision making system. Okay, so we'll see what is the difference between OLTP and OLAP. Here it is supporting business users, OLAP is supporting business users, and OLTP supporting end users. And OLAP supports for analysis process and OLTP supports for transaction process. Analysis process in the sense, so once we build the data warehouse, so it's a centralized database. From there, business users will be able to generate a report or reports to take good decisions to improve the business or process or increase the sales, whatever it may be. So to in one word we can say to improve the business, they can generate such kind of reports in order to take good decisions. Here transaction process, completely it's based on the transaction. It's a live transaction. A customer is doing a transaction with the business, so that transaction will be captured in the application. So that data will be captured on OLTP database. Now, validation of queries. Here, often complex queries, simple queries. Now, in OLTP, very simple queries, because the structure designed in a relational model. It's a simple queries because the structure designed in a relational model. Here we have some complex queries will be there in dimensional model. So we'll see what is dimensional model and what is relational model in next slides. Now, processing speed depends on the amount of data involved. So it's because why we are talking about depends on the amount of data involved, because as we are talking about this database, it is a data warehouse database. uh, Data warehouse in the sense we have to maintain huge amount of data in the data warehouse. So huge amount in the sense it can be a terabytes or zettabytes, okay, not less than gigabytes. So it is nothing but a huge amount of data. When we are processing some query, when we are writing some query against that database, so it will be taking time to give you the results. So that is the reason it will take some time in order to get the result in OLAP database. Is nothing but data warehouse database. So here in the OLTP database, the data will be very small, database would be very small, data will be, very less amount of data will be available in the OLTP databases. That is the reason here we need a very less amount of time in order to process query. Any questions, guys?
No.
Srinivas?
No.
Fine.
No.
So this is the relational model. Here we have employee table here. Is this employee salaried or it's the employees hourly based? So these kind of relationship we maintain in the OLTP database. So not only this, in each and every table will be having subtables, and that subtables will be having again subtables. This is the relationship we maintain in the OLTP database in relational model. So I'll be giving you separate notes for this if you require. What is the relational model? How to maintain relationships in the OLTP databases in relational model. So you can see all those things. Okay. I honestly speaking, guys, I don't really focus on theoretical part. I'll be completely driving this meeting in a technical way. Okay. So dimensional model. Here we have the facts and dimensions concept in the data warehouse database, OLAP databases. Now here we have sales fact and the dimensions, store dimension, product dimension, customer dimension, date period dimension, sales order. Now if we can see here, employee details itself we are maintaining in 3 tables. Employee details itself we are maintaining in 3 tables. For example, one employee is there, that employee is salaried or hourly based or employment details, everything we are maintaining here in 3 tables. But if you want to maintain the same data in the dimensional model, we may maintain in a single table. Is nothing but employee dimension. Another dimension will be coming into the picture. It's called employee dimension. So we segregate the data of, whatever is possible, we segregate the data and we maintain that data in a single table. Single dimensional table is nothing but employee dimension table. Okay, all the dimensions dimensions connected with a fact. What is dimension table? What is fact table? We'll see in the next slides. So here we'll be having 1 second, guys. sorry guys, here we'll be having dimensions and facts. This is a dimensional modeling. Now, there in OLTP database, it is a relational model. We'll be having a relationship with each and the other tables to maintain in order to maintain the data, respective data. The same way, we segregate the data and we maintain the data in the dimensional tables in dimensional modeling.
I have a question, Ravi.
Yeah.
Yeah, why do they go for this dimensional model for data warehousing?
Right. So in order to process, in order to generate some reports, okay. So if you want to maintain, if you are maintaining a relational database, so there would be huge amount of joins. There would be huge. For example, if you see these three tables information, we are maintaining in a single table in dimensional modeling. So to get the data from the dimensional model is very easy and very faster than the relational tables. So here we maintain history of data, and here we have less number of joins. Here we have huge number of joins in OLTP relational model. Here we have very less number of joins in dimensional model, as well as we are able to maintain the history of data in dimensional model, not in OLTP systems. OLTP systems we cannot maintain history. So from dimensional model, we are able to generate reports based on the current date, based on the past prior date, or last. If you want to make a report from last 1 year, you are able to generate a report for last 1 year, but not in OLTP application databases. Here, moreover, here you have less number of joins. When you are processing a query, for example, if you are generating a report, when you are trying to generate a report from the application side by using any of the reporting tool backend, what it would be doing, it would be creating a SQL query. That query will be processed against the database of this dimension model or data warehouse database. So that will be fetching the result, and it will be giving you another in the form of report. So when you are trying to process the same query with multiple joins, the process time would be huge. Processing time would be huge. In order to reduce the processing time, when we are talking about the technical things, in order to process the query very fast, so we have to maintain this dimensional model.
Okay, but there should be some downside for this model also, right? Like when you are making, you are like denormalizing it. So
right, right, Deepa, you are right.
So yeah, so what are like downside, like when you denormalize, there are again like so many tables, and you have to maintain like so many tables and all that. So so it is not like cost wise, like
no.
or memory wise.
Yes, Deepa, you are right. See, here here we have a complete information in a three tables, right?
Yes.
So we are segregating this information. We are maintaining all these three tables information. We are maintaining a single table. Is nothing but employee dimension here. So that means we are extracting the data from three tables. We are loading that data in a single table, right?
Yes.
So 1 second, Deepa. Sorry, Deepa. Now,
Okay.
here we are segregating the data of the OLTP databases, and we are maintaining these data in a dimension modeling, dimension format. So we have all the data in a single page. Like there is no need of downstream applications here. It's a denormalized data. When you want to extract data from, for example, if you want to see the complete employee information. So now you have complete employee information in a single table. There's no need of join with other tables, right?
Mm-hmm.
So similarly, look at this picture. If there is a store dimension, complete stores related information will be available in the store dimension. Similarly, date dimension, customer dimension, product dimension, sales order dimension. If you want to see how many sales happened in 1995 year for X product and store wise, what are the information you need here? Store information you need, sales information you need, and the date and time information you need. So the complete data is available in 3 tables. If you compare these joins in a relational model, here you might have 9 tables here.
Okay.
So you might have 9 tables here in this relational model, but we reduce the number of joins by maintaining data in 3 tables. We have store information in a single table, sales order information in a single table, and date related information in a single table. So by joining here, we need to have 3 joins in order to get that report. If we are generating the same report on this relational model, we may have 9 joins.
Okay.
So that will be causing more amount of time. It's not in terms of cost effective. In terms of we really care about the timing, because
Okay.
a top level manager after a generate report button, after pressing generate report button, he cannot wait for 2-3 days.
Mm-hmm.
He cannot even wait for 10 minutes. Instantly he need a report.
Yes.
So the data warehouse is supporting such kind of queries. Okay.
Okay.
Yeah.
Okay.
And here, if you can see, what is dimensions and what is facts. So dimensional tables contains a descriptive information, like complete detailed information about that particular area. We are talking about product dimension, complete product code, product name, vendor name, complete information about the product. So we maintain complete information in the dimensional tables. When we talk about fact, all the dimension keys from the dimensions will be loaded into the fact with the appropriate measures. If you can see, product code is a primary key of the product dimension. So the same product code was loaded into the fact table in a blue color. Similarly, time dimension, time code is there, and customer dimension, customer code is there, and geography dimension, so district code is there. So these are the keys from the dimensions. In the sales fact, if you look at sales fact, the middle one, so the 4 are keys from the different tables. The 4 are different keys from the different 4 tables. And the downside of in the pink color is revenue, cost, units sold, net profit is nothing but measures. So we call these keys as facts, and the downside of the revenue, cost, units, net profit is nothing but measures. Fact table will be having facts and measures only, and dimensional table having complete detailed information about that particular table. Here, what is data warehouse? So we discussed about data warehouse. We have some knowledge about that, but what exactly it is? So subject oriented, integrated, time variant, non-updatable collection of data, using support management decision-making process. So, subject-oriented. What exactly a meaning of this subject-oriented? If we go back to the slide, you'll come to know. See, this is one. See, we have some information related to employee right here. So, we segregate the data based on the subject. Employee is the subject. All the employee-related information we maintain in a single place. This is nothing but a subject area. Try to understand. We'll discuss what are the subject areas, what exactly a subject area is. But just to make you understand, I'm giving you this example. So, we segregate the data based on the subject area. Subject area may contain multiple tables. Subject area may contain multiple tables. Just make you understand, I'm just giving you. We segregate the data based on the subject area and we maintain the data. Now, here we will create some certain subject areas based on the project requirement. Okay, based on the project requirement or based on the model. So different companies may follow different models. Based on the model or based on the requirement, we create the subject areas. So we can, in a single word, it is subject oriented. The data will be captured from multiple source systems based on that particular subject. Store subject area is there. For example, the complete information from various relational tables. We collect the information from the various relational tables and we load that particular data in a store subject area. It is integrated. We integrate the data from various sources. Time variant. We load the data into the data warehouse based on the frequencies of the loads. Now, it's a kind of, for example, now we have loaded the data into the data warehouse. So there will be some time frequency in order to capture the CDC. Now, what is the CDC, Deepa? You have any idea? Srinivas?
No, I don't have any idea.
Change data capture. So in order to do the change data capture, we maintain the time frequencies. Here you can see can study trends and changes. So we capture that. We have to capture that. In order to do that, we maintain some frequency. It can be a day, it can be a week, or it can be a month. Non-updatable. So it is a read-only database. We cannot edit it or we cannot delete it. It's only read-only database. So we can write queries, we can read the data, we cannot edit and we cannot delete it. So it's a periodically refreshed in the sense when changes are coming into the picture, when in the new load. For example, now we have a data for last 1 month. So now we have loaded that last 1 month data in our data warehouse database. Now there would be some business changes happen, business applications capture new data. In the data, there are some changes in the existing data. So we have to capture that existing data changes as well. So we'll maintain that data, we'll maintain history, but we don't delete any previous history. We maintain that history, but we don't delete any previous history. It's nothing but periodically refreshed. It's read-only database. You cannot delete that database. We cannot edit that database. It's read-only database. Any questions, guys?
No.
Deepa, you are saying something?
I said no.
Fine. Now, these are simple data warehouse architecture. Okay, so these are the different sources. You may have CRM sources, ERP sources, e-commerce sources, SCM, legacy, external, other sources. So we may have different kind of sources here. in our data warehouse database. So based on the project, okay, based on the clients, you may have different sources. So ETL will be, to come into the picture to extract the data from various databases. Our Informatica tool will be able to extract data from all these sources: e-commerce, CRM, SCM, legacy, external, Oracle. It can be anything, any database. We are able to. Informatica 9.5.1 supports web applications as well. Apart from these web applications as well, clouds also, big data also, Informatica 9.5.1 supports. Okay, so we are able to extract all this data from data sources, and we maintain initial staging area. Staging area is nothing but, it is also a temporary database where we maintain a unique format of data. So here we maintain a unique format. For example, CRM, you just extracted CRM data, the first source, which is in data sources. You extracted CRM data, you just dumped into a staging area. So the structure will be available in staging area. You just dumped into the staging area. So similarly, ERP data, legacy data, external data. So all the data you extracted and dumped into that staging area. So the name itself, it is a staging area. Extracted and dumped into a staging area. Then we do, as discussed, data cleansing, merging, aggregation. We do different type of operations on the data based on the business requirement and business rule implementation. It's nothing but transformation.
All those we do in the staging area?
No, not staging area. The next level to staging area, in order to, in between staging area and the data warehouse.
Oh, okay. Staging area, we just dump everything, and after that, during the transformation, you call it as like cleansing, scrubbing, whatever.
Yeah, cleansing, grubbing, CDC, all these things.
So staging area, just you will dump everything. That's all.
Yeah, again, it's based on the, we may have one staging area, we may have multiple staging areas. So it's completely, this is a simple data warehouse architecture. So we are discussing only one staging area, but we may have multiple staging areas in real.
Okay.
So in that case, we may do different activities in each staging area. Now,
Ravi?
Yeah.
Oh, quick question here. So when you say the multiple staging areas, what does it mean by multiple staging areas? Generally in data warehouse, we use only one staging area and simply we dump the data wherever it is coming from, the different upstreams, okay? So directly it will store into the staging area. It's like more or like a truncate and load daily process. So
Right.
what do you mean? What do you mean by for the different staging areas? I couldn't catch you that exactly.
For example, I have some junk data. Okay, in order to process that junk data into transformation level. So I don't want to do that. I don't want to waste my time and the application time. So I want to just remove the junk data in another staging area. Just it is a kind of dumping into another staging area. Here we have extracted and we have loaded into a single staging area, and then I remove a junk data from this data and I've loaded this data into another data. Same as you say, this is truncate and load database. Still, we have done something on the existing data and we have maintained another subject area. That is also a truncate and load daily processing.
Okay.
This is, it's a kind of, business requirement. Srinivas. It's a kind of business.
Yeah, I understand.
It's you understand, right?
And yeah, I understood you.
Yeah. So it's based on the business requirement. It would be, we can maintain one or two. Fine. Now next, we loaded the data into a data warehouse database. So here metadata repository, MDM, master data management. So here metadata repository will be taking care of all these metadata, table structure, table data types, table column level information, everything will be maintained in a metadata repository. Now Once the data is loaded into a data warehouse database, then so we have here two approaches. One is top down and bottom up. So we may maintain data warehouse first, data warehouse database first, or data marts first. Now here in this architecture, we have data warehouse first, then the data will be loaded into a data mart. So we'll see what is data mart. So from the data marts or data warehouse, the BI reporting tools will be coming to the picture. So BI here, BI reporting tools will be able to generate reports in order to answer the management queries, senior level management, junior level management, top level management, whomever it may be. If they want to see something about the business, so they simply use some tools and they try to generate reports regarding the business, and in order to take a good decisions to improve the business. So now, what is a data mart? You see, now we have all the sources, and we have staging areas, we have data warehouse, then finally data processed into data marts. Now we have here HR data marts and account data mart. As you can see here, three data marts are there. Let's assume the two data marts are from HR and accounts. Now HR data, from we have some set of users. So this data mart is mainly built for support that particular users. For example, a top level management has different kind of users. So those users we may not give those guys may not have complete data warehouse access. Those guys want to see some data related to HR, and accounts guys want to see accounts related data. So in order to process individual users category wise, so the data mart will be supporting their queries. So data warehouse is for complete decision making system, and data mart is also a decision making support system, but here we'll be having less amount of information. This is limited to HR data mart, and this next one is accounts data mart. Still, these guys able to generate the reports about account information as well by including HR information. How they are able to generate? In case if it is required, they join this HR data. Already it is available in the data warehouse. What we need to do. We need to have a proper join of the HR data and account data, and they are able to generate the reports in worst case. But here it is supporting a different for account data mart is supporting for some guys queries, and HR data is supporting for some guys queries. Okay. It's a subject of data warehouse. So we discussed about the ETL process: capture, extract, scrap data cleansing, or data cleansing, transform, and load. The same thing. Now we have different types of schemas available in database data warehouse. Now we'll discuss star schema and Snowflake schema. We have Galaxy schema as well in the picture. If you really require that, so I will be able to give you the information about Galaxy schema. But as part of our training, we are talking about star schema and Snowflake schema, because these schemas are very much popular in this time now. So in the star schema, all dimensions would be surrounded by a fact. Fact is surrounded by all dimensions. Each and every dimension would be connected to a fact. Each and every dimension would be connected to a fact. So it looks like star. There is a reason we call it as star schema. So each and every dimension, don't forget, each and every dimension table is connected to a fact, Now, when we talk about the Snowflake schema, so dimensional tables will be connecting to a fact, but these dimensions will also have a sub-dimensions. Is nothing but Snowflake schema. These dimensions will also contain sub-dimensions. Is nothing but Snowflake schema. Here, only dimension. This is the ending of dimension. So the dimensions will not be having sub-dimensions here. Now, here in this Snowflake schema, we have sub-dimensions to the main dimensions. Nothing but Snowflake schema. This is the Informatica architecture. Now, here in this Informatica, we have this is the client-server architecture. Now, we have here in the domain integration service and repository service. Integration service, repository service. So we'll connect to the databases by using ODBC drivers. Similarly to the source, also native or ODBC drivers in order to extract the sources. So integration service will be taking care of all these data integration, and repository service will be responsible for maintaining all the metadata information, complete repository level information in the repository service. Integration service is responsible to maintain in order to integrate the data, that sources. And
Ravi.
Yeah.
In the previous slide, like you have shown that MDM, the repository, right?
Yes.
When you're showing that ETL, the data warehousing, data marts, that diagram. So there I have. Let me go there. Yeah. No. Can you go front? No.
No, she's talking about the metadata.
Yeah.
This one.
Yeah,
right?
this one.
Yeah.
That metadata repository MDM. So that one is the repository. You have shown another diagram recently. So that is with the metadata repository.
Yes.
Is that the repository service or repository?
Yes, Deepa. Right, you are right. So here it is responsible for. It is responsible.
So in this diagram, where is that one? That MDM?
Repository service.
Repository service, because down I see one more repository, small.
No, not this is the repository service. This is the repository service stored in a repository.
Okay.
We'll discuss in the when we see the tool, you'll come to know what is repository service and what is repository.
Okay.
Okay. So yes, as you said, integration service is responsible for integration of data, and repository services for complete repository information. As you say, MDM, master data, complete metadata, complete information will be maintained in this repository service. So now we have administration console to handle complete this integration service and repository service. We have administration console. It is nothing but we can control repository service and integration service with admin console.
So all this should be up and running all the time?
Yes, all this should be up and running all the time. If anything is down, we cannot process anything. If integration is service
even when we are developing a mapping, all this should be up, like to use those transformations, all that.
Yeah.
Or only when we are running a work.
No, Deepa. When we are trying to do something in Informatica tool, everything should be up and running. For example, you're implementing a mapping. So something good. The repository services went down, for example. You cannot save that mapping. You cannot save your work.
Okay.
So in that case, it should be up and running. Okay. So here we have Informatica PowerCenter. We have repository manager, Informatica designer, workflow manager, and workflow editor. We have 4 type of tools available in Informatica. So we'll see all these tools in detail in our regular classes. Now, this is the Informatica repository manager, Informatica designer, workflow manager, and workflow manager. So apart from this, we'll be covering a project, Deepa and Srinivas. So the project is this. This is an insurance project. So how we will see what are the source systems, what is the different layers to maintain in our, in order to maintain data warehouse database, to serve the end users queries. So this is a project architecture. So we see what exactly we do in this project. So what is the different layers to maintain? What is the necessity of maintaining layers in this project? So, the complete explanation, complete information will be given about this project. Like this is a sample document. The point. This is a kind of design document. How the design documents would be, how to understand the design documents, how to in order to, for example, we cannot just go blindly and build the mappings. So we need to have a proper understanding about the requirement, proper understanding about the architecture, proper understanding about the documentation. So we have to understand that first. When we have a proper understanding, then we are able to build our design mapping. So what transformation need to be used, and what is the business logics they need to implement it. Okay. So what complete information is available in this, and the document is nothing but mapping document. These are nothing but design document, and this is nothing but the mapping document. So here it will be giving you a proper information for each and every column level. So what needs to be done? So how to implement that particular column level business rule information. So complete information will be available in this mapping document. So by understanding both the and design documents, we'll be able to design the mappings.
So this will be developed by architect?
It depends, Deepa. Again, it depends. So, for example,
no, not by Informatica developer, right?
No, generally mapping documents developed by the data modeler. So it's like this is a kind of a TTS document which is developed by the data modelers.
Oh, right. So in some cases, Deepa, if it completely depends. I can say it's completely based on the project. So when we are starting from the scratch, okay. So we may not have documentation. If we have documentation, everything is in place. If we may not, if we don't have documentation, then we may involving into developing these kind of documents with the help of data modelers.
Okay.
It's completely, it depends. So we have to be ready for everything. We have.
Yes. Yeah, in that project I have worked, they did not have any this kind of mapping document. They just said like, this is need to be done. So that's why I'm just asking like, is this need to be usually in any company, like is it only by mapping developer or whoever, or a data modeler? So
yeah, basically 90% of the projects will be having proper documentation. So still we have kind of projects. Even I am working for some other project at this moment. They don't have any documentation. So we have to assume and we have to do it. So it completely depends. It's not like all fingers are not same. All projects are not same. Based on the requirement, we have to make ourselves available, and we have to work accordingly. So this is all about demo, guys. So if you have any queries and any questions, you please ask now.
Ravi,
yeah.
Are we using any specific framework here, or is a general Informatica framework?
Any other framework in the sense, Srinivas?
a framework means like, whatever you so far you explained, the data coming from the source systems and directly loading into the staging, and from there the transmission.
Right.
So instead of that staging, nowadays the people are using in the files and acquire phase, and coming to the picture of the rebel, parallel, and the testing also come into the picture. That the kind of different kind of frameworks nowadays using in the market.
Yes, but here we are not using any frameworks, Srinivas. This is a training, driven in a normal format. Okay, we don't use any frameworks. We don't have access basically to use frameworks.
Oh. Okay. Okay,
And
fine.
You might be using some slowly changing dimension.
yes,
type
obviously
one, type two.
that is our part of training only. We have complete in detail push down optimization, slowly changing dimensions, SQL overriding concepts, lookup overriding concepts. So everything, performance tunings, debugger, everything will be used. But not frameworks. Frameworks not only here, but we don't have access to use that frameworks. And apart from this, as you discussed, ETL testing, that is a complete another part of training. But still, we can cover some of ETL testing concepts in our training, if you require.
Okay.
So for the
for
the real-time project, okay, what kind of database you are using?
So we are using Oracle 11G or 12C, yes, Oracle 12C.
Okay.
Any other questions, Deepa?
No, I'm fine.
You are fine, right? Srinivas, from your
I'm
side?
fine, Ravi. Yeah, I'm fine. Yeah, I'm fine, Ravi.
Yeah, thanks, Srinivas. Please, leave your feedback to the coordinators.
Yeah, sure, definitely. Yeah.
Thanks, Deepa and Srinivas. Thank you so much.
Thank you, Ravi.
Thank you, Ravi.
Yeah.